We do have, this is a picture of the Solarc 12K here. Some of the big features, we have a color touchscreen display, which makes programming and viewing what's happening on the inverter super quick and easy. We have a 48-volt battery input with a built-in battery disconnect. This is a 225 amp breaker. We've got built-in PV disconnect at the bottom of the system, which you can't quite see here in the photo, but it's right below the little knockout area there. And the PV plugs into these little white tabs right above it. We have all kinds of sensors that can plug into this little gray bus bar here. Battery temperature sensor, auto generator start, rapid shutdown, power supply for the little transmitter, CT sensors for using meter zero mode, battery communications, all that good stuff. And then on the right side, we have all of our AC connections. So we have the load output, which is for your backup panel, backup loads. We have our grid input-output breaker, which we use for doing either meter zero mode, charging from the grid, or selling to the grid. And then we have our generator port, which is kind of our Swiss Army knife breaker. We can either use that as a generator input, an AC coupled input, or we can do what's called a smart load output, which is essentially a automatic load shedding kind of deal. Much better. Thank you, Andy. Yeah, so the smart load's pretty cool. You can say only power this load if the batteries that are at least at a certain SOC, state of charge, or you could even say don't power this load unless my solar panels are making at least, 500 or 1,000 watts or something. It's really useful for reducing the minimum size battery bank you have to have for off-grid performance, because you can basically set it up to only power stuff like water heaters and air conditioning units if the sun's shining, which is a pretty nice feature. As Andy mentioned before, monitoring is built in, or at least it comes with it. It's a removable dongle, but it comes in the box. And there are iPhone, Android apps for that, as well as a web portal. And something important to note about the case here is that it is NEMA 1, so this the case by itself has to be installed indoors. However, there are some options available if you need to do an outside install. Simplify makes a pretty cool case. They call it the Access case if you need to put it outside, or I've seen other boxes available on the market if you need to put it outside. We did do highly accelerated live testing on the system, though. It can handle really high humidity, and it can handle being almost outside. It just doesn't like to get rained on. So it does pretty well if you have it at least pretty well covered so it won't get wet. The 12K unit can do up to 9.6 kW of grid sellback. And you can technically hook up 16.5 kW of solar panels to this unit. But its maximum production is going to be 12 kW, and we split that up between grid cell and battery charging simultaneously. So if you were doing the full 9.6 kW to the grid, you could do another 2.4 straight to the battery at the same time. This system also has a pretty impressive peak power rating on it, 20 kW for 5 seconds. So we can do like a 3-ton AC unit with just one of these. Then our MPPT inputs, we have 2 of those built in. Each of them can do 20 amps and go up to 500 volts on the input. And then we have 50 amps of AC pass-through from the grid or a generator to your loads. All right, so that's it for that slide. Andy, if you can move me forward. Okay, so here's our, So this is a close-up of a couple of the screens available on the touchscreen. The home screen here on the upper left displays what's happening in real time on the unit. So in this example, you're making almost 6.5 kW on the solar panels. You're selling 4 3/4 to the grid, and you've got a little bit left over going to your load panel, and the battery's already full. Now, you could, and the one right below that is kind of a grid cell example only, and it's just basically selling everything over to the grid in the bottom example there. Now, if you touch the battery icon, which is the one with the green box around it here on this bottom photo, you'll get the screen on the right. Now, this screen is, we call it the voltages screen, and it's a really useful way to make sure that the install was done correctly or see what's going on with the inverter. If you have a problem with any of these numbers, they will light up in either yellow or red highlight to let you know that that's the issue at hand at the moment. But I'll just go through like each column real quick so you guys have an idea of what they all mean. So the solar column, you've got your total wattage being produced at the top there, and then L1 and L2 breaks up your voltage, amperage, and wattage per MPPT. So L1 is MPPT1, L2 is MPPT2. And then the grid column is same thing with the wattage at the top. All the columns at the top, everything at the top is just the total wattages. But you'll get your hertz of the grid, the voltage pretty straightforward. But these little HM values, these are what the measurements coming off of the current transformers. So we use these sensors to do meter zero mode, peak shaving, generator assist, those kind of things are what we use the HM values for. And we also refer to those as limiter sensors in our manual, just so you know if you get confused there. They're just current transformers that we use for measurements. The inverter column is just like the grid column, but this is what the inverter is actually producing. So L1, L2, voltage, amperage, wattage, pretty straightforward. The load column, this refers to what's going to the load breaker. And if you're in limited to home mode, the load will also include what's being contributed to the household. And if you're in limited to load mode, or really any other mode, it just means how much power is going to the load breaker. Then we have our battery stuff, wattage, SOC, voltage, amps in or out. This little temperature right here at the bottom, or almost the middle of the screen here, this is negative 20. If you see negative 20, that is the default value. That means that your temperature sensor just isn't hooked up. So if you see negative 20, that's what's going on. I really recommend using the temperature sensor. You probably kind of have to if you're going to have a lead acid battery, so we can do temperature adjustment for that. If you have a lithium battery, I still recommend you install the temperature sensor, but it's not as necessary because we don't do voltage compensation for lithium, or temperature compensation of the voltage with lithium. And just so you guys know, the battery temperature sensor is pins 1 and 2, and there's no polarity, so that one's pretty easy to put in. And then lastly, we have the temperatures at the bottom. Those are just the temperatures inside the inverter, the DC section and the AC section. All right, Andy. So here is the absolute most basic install you can do with a Sol-Ark. This would be a grid cell example with no batteries. So this is basically just us acting like a run-of-the-mill grid tie inverter. If you want to, this is a really nice option to have if you have a customer that you feel like probably will want batteries in the future, but they either want to wait for a new chemistry to come out or are price sensitive or something along those lines. You can set them up like this first with a net metering agreement and then come back in at any point in the future and add a battery really easily. So to set up this mode, you just set it to grid cell mode only and no battery mode. If you don't check no battery in your battery setup menu, the system's going to beep at you because it's looking for a battery. So just know that you have to go to your battery settings and select no battery for that. I do have a question here. What is your preferred lithium battery system? So I do have some slides on that coming up here in the future, but there's a lot of really good batteries out there. Some that come to mind off the top of my head are, we got Simplify, Fortress, Discover, Blue Ion. They're all good batteries. We do prefer the lithium iron phosphate chemistry in most cases, as opposed to something like an NMC or NCA. So I guess I'll hope that answers your question for now. Andy, I'm ready for the next slide. Okay, so here's just a quick explanation of our PV inputs. So you can do, with an 8K, you're limited to 4 strings, and with a 12K, you can technically go up to 6 strings. If you do 6 strings, you're going to need to have an external combiner to combine 2 of the strings before they get back, because we only have 4 inputs physically. But the 12K can handle more amperage and more wattage, nameplate wattage attached to it. Our MPPT voltage range is 150 to 400 with a maximum of 500. If you hit 500 volts, we will stop producing any power. We basically shut down. And if you go over 550 volts, you will damage the system. So make sure to do your temperature compensation accordingly. We do have built-in arc fault and GFI detection, so that's pretty nice to have. Save you some money there. You don't need those arc fault breakers. Our maximum short circuit current connected to the solar is going to be 33 amps. So if you need that for your permitting process, or if anybody asks, that's how we get away with 3 strings. Now you probably will notice here that we show fuses in the drawing here. I'm getting some audio from somebody. You can mute yourself, sir. Are you asking a question? Okay. I do have a question here. Will the inverter... Okay. Yes, it will. Oh, wait. The latest Rule 21 essay requirements due in June. So, yeah, the latest requirements were pushed back, and we should be ready to go by then. I don't see any reason why we won't be. We've been working on it for a while. Okay, and then the last thing I wanted to mention on this screen is just that these fuses here, they're only required if you're doing 3 strings in parallel. They are not required if you're only doing 1 or 2. That's just a code thing. All right, Andy. Okay, so this slide kind of demonstrates the benefits of a high voltage MPPT versus a low voltage MPPT. It's pretty much just copper savings, a lot of copper savings. So the low voltage MPPTs require quite a bit of copper, as you can see here, versus the higher voltage, you can get away with much smaller wire and a lot less of it, which is less labor in the install and less money up front for supplies. Also, again, since we have PV arc fault built into our system, you're saving some money on not needing these arc fault breakers. Go ahead, Andy. Okay, so here is our standard install. This is the most common way that folks will install a Sol-Ark, either an 8K or a 12K. Pretty similar to the grid tie example, but now we have a sub-panel that we're powering on the load breaker and a battery. So it's pretty straightforward. In this example, while the grid is up, we will contribute to the load panel as well as, the way this one's programmed as shown on the right, the system is in grid cell mode, so it's going to sell back as much power as possible from the solar panels, and it'll keep your batteries full. And then in the event of a grid outage, the batteries will take over and power the load panel. So you'll have battery backup for whatever's in this sub-panel. We do highly recommend sub-panels. If you have an older house, you can get away with using something like a 10-circuit transfer switch as your sub-panel, which is easier to install and a little bit cheaper. But most newer homes, if you have like GFCI breakers or arc fault breakers or both in your main service panel of your client, you will want to install a sub-panel so that you don't have neutral path problems. But a quick note on that too is if you're using 12Ks and you have enough 12Ks, as I think we have an example later on in the slides, you can actually just full-time power the whole panel, which is what a lot of customers like to do. They don't have to have any transfer switches or preferred loads or anything, but we'll get onto that in a little bit. As far as the voltage on the battery bank, the standard is going to be 43 to 59 volts for units that you get, but we do have a higher voltage model upon request. So if you have somebody that wants to use kind of a wet cell battery or some other oddball battery like maybe like a nickel iron or even I think lithium titanate requires a little bit higher voltage, but we have a 63 volt model upon request for that. And the battery bank sizing, we have a 185 amp charger on board the Solark, so the size of the battery bank is pretty much as big as you want to make it. Let's see. Okay, and one last thing here, we are UPS battery backup, so if you do the sub-panel route or you have enough inverters to back up the whole panel, the customer's not going to even know that the power grid went out. It'll back it up so fast that their computers won't glitch. We call it kind of a no glitch transfer time. You've probably heard of an uninterruptible power supply, but we are one of those for your loads. Okay, next slide, Andy. Okay, so here's an AC coupling via the load breaker. I don't think I mentioned this before, but we can also do AC coupling through your critical load panel on our load output. This tends to be the most convenient way to wire it if you already have pre-existing AC inverters, like a SolarEdge or microinverter, something like that. It's usually easier to just land it in the sub-panel that you're powering. Also, the limit is higher if you AC couple on the load breaker than it is on the gen breaker. So you can do 9.6 kW of AC coupled inverters on the load side, whereas you can only do 7.6 if you AC couple on the generator breaker. Although if you do have 7.6 or less, we do recommend the generator breaker, as I'll go over a little bit later, but it still works totally fine with the load side, and we use frequency shifting or frequency curtailment to control that inverter's output so we don't overcharge batteries or anything like that. If you do AC couple on the load breaker, it does basically use up the generator input in software, so you can't use the generator input for anything if you're AC coupling on the load side. So if you're trying to AC couple on the load side or the generator side, but you still want to use a generator, you can just put a transfer switch on the grid input here and have that go to your generator or the grid, which I think I have an example of coming up here soon. Here we do show CT sensors for the first time. They just go in between your meter connection and wherever the grid, the Solark is connected to the grid. So in this example, we have a pretty standard setup. We have a 50 amp double pole breaker in the main service panel. So that's the easiest standard way to do it. Depending on where you are and what kind of breaker panel you have, sometimes the 120% rule comes into play. So you may need to do a line side tap in that case. Or you can software limit our inverter to 7,600 watts of output, and usually you can get away with a 40 amp breaker in the main service panel. So that's a couple ways to get around that problem. And lastly, we can do DC coupling and AC coupling at the same time. But you need to make sure that the wattages are appropriate on both sides. So, for example, if you were doing 9.6 kW AC coupling, you would only have an additional 2.4 kW of DC coupling available to you, but you could do both at the same time for maximum production and output. All right, next slide.
I would like to add that we do include these CTs with every system. So if you sometimes I get the question, do you have to go get those? No, those are included. So just thought I'd mention that.
Okay, that's true. We do include those. And here's basically the same thing, but your AC coupling is done on the generator input breaker. And the reason we would prefer to do this if you have a smaller AC coupled solution is we just have a little bit more control if you use the generator breaker. The reason it's limited to 7.6 instead of 9.6 is because our generator input breaker is 40 amps, whereas our load output breaker is 50 amps. But the extra control that we have is the generator breaker runs through a software controlled relay first. So if we ever needed to, we could just totally disconnect those panels altogether, which gives us a little bit more control. I do want to mention a little bit about those programming settings up at the top there. If you go to the Smart Load tab of your battery setup, this is where you will select that you're doing microinverters, or actually I think in the new software version this just says AC coupling in general. You just have to check that box to change what the generator breaker does, and these Smart Load on-off values will change their meaning if you're in AC coupling mode versus Smart Load. So in AC coupling mode, your on value should be below your off value. And we do recommend 80 and 90% respectively there. So basically what that means is if the battery is 80% or lower, we activate your AC coupled panels. By the way, this only applies off-grid. When you're on-grid, of course, it'll just be a straight pass-through to the grid. You'll be able to do grid cell that way, but when the grid goes out, in order to make sure that we have somewhere to put all the power that the AC coupled panels are producing, we will not start using their power until the batteries hit, in this example, 80%, and we'll stop producing AC coupled power when the batteries hit 90%. And that's so that you don't overcharge the batteries and you always have somewhere to put that power. Okay, moving on here. So some of our key features here compared to a lot of our major competitors is going to be efficiency. You can see here that our PV to AC efficiency is right up there with the best of them. And since we're a hybrid inverter, so we're a transformerless inverter, so we're kind of the best of both worlds. You can see that the AC coupled solutions have high efficiency when selling back to the grid, but the DC coupled solutions are kind of lack in this area because they're always going through the battery first. So we're an inverter that can use a battery that doesn't have to go through the battery for grid sellback. So we're basically an AC coupled inverter whenever the grid's up, and we switch over to DC coupled more or less whenever the grid goes out. But we're still transformerless, so we're even more efficient going through the battery. So it's the best of both worlds there. Our warranty stacks up, so the 12K inverter does have a 10-year standard warranty, whereas the 8K has a 5-year standard with an option to, we have another SKU available that does come with a 10-year warranty for a little bit a higher price there, but it is available. So I think, oh yeah, and our MSRP, so I believe you guys are dealers, so obviously you guys can talk to Andy in the sales department about your pricing, but MSRP here, the 12K is $6,850 and the 8K is $6,100. So I think that's let's see, for the bottom here, we do have 12 kW maximum DC production from the panels, like I mentioned earlier. And then we can do another 8 to 9 kW tour from the batteries with a maximum grid cell back of 9.6. So it kind of balances in real time how much power is going to the grid versus the battery to try and maximize your PV production. So if you were charging the battery at 8 kW, you'd only be able to sell back 4 kW to the grid, or vice versa. If you were doing 8 kW to the grid, you could do 4 kW to the battery, or any combination thereof, basically, that adds up to 12 kW. Without exceeding the maximum on either side. So, next slide, please. Okay, so this would be the battery side of things. So when we go from PV to battery to AC again, we only lose 7%, whereas you can see everybody else pretty much loses significantly more than that. So that's going to be one of the biggest benefits. And it saves the customer and you guys quite a bit of money too, because we can get more power and more usefulness out of a smaller battery. There's, some of these examples you're losing 15, 20, 25, 28% even sometimes of the energy that you put into the battery by the time you take it out because of all the different transitions, like especially the AC coupled stuff. And that's because they're going from DC to AC, transmitting that via AC back down to DC, and then from DC up to AC again, just to do backup power. Whereas we can go straight, we can bypass a lot of those conversions, and that's why we're only losing 7%. Next slide. So here's a quick, just how we compare on pricing to something like the Tesla. Everybody knows Tesla, so a lot of folks like to see how it stacks up there. A quick note too is, actually I think we'll show it here in a second, but the Tesla batteries, only last for 10 years, whereas you can pair whichever battery you like with us, so you can easily pick one that'll last for 16 years, such as LFP. So we'll go ahead and go to the next slide real quick. Here's just us versus the Sonnen unit, and yeah, here's the slide I really wanted to show you guys. So Actually, let's go one more forward. There we go. Okay, so as I mentioned before, the Tesla battery is only going to last for 10 years, so the initial upfront cost does appear to be very similar between the three options here, but whenever you factor in lifespan and PV efficiency on the battery sizing, as well as some inverter output settings, you do see that there is a pretty significant real cost difference between these. These are all MSRP numbers, and they might have changed since the time we made the slide, but I think that it holds true in general here. All right, well, let's go ahead and move on. Here's just another example between us and some other folks. Okay, yeah. Now we can go ahead and skip through that. It's basically the same thing there. I do want to talk about the LG Chem's warranty schedule here. I do give them credit. They're very transparent about their warranty, but this is just a good example of some of the downsides of an NMC chemistry. You can see that in, let's see, what is this, year 9, you're only going to get 2% of the purchase price back with this warranty, and you get a decent warranty at the beginning there, but it drops off super fast. So you hit year 6 there, and you're already at 16% of the purchase price, and so on. This is just kind of interesting to see and to be aware of with some of these solutions that quote unquote have a 10-year warranty, but at least they tell you up front that you're not getting much back if it fails late in life. They do claim to be they claim and they are a 380 volt externally for these battery banks. And you might think that that's really efficient, but internally the battery is actually going down to 50 volts again, and then back up to 380 whenever you go out. So these are actually really inefficient batteries, even though they're sold as being more efficient because of the internal DC to DC conversion. As you can see, they're losing about 11% here, not even including the inverter and all that other stuff, but this is internal conversion there. Also, temperature on these batteries, they don't like to get cold, as you probably have heard. You charge these batteries when they get cold, and really bad things happen, and usually your warranty gets slashed. But that's it for that. Just wanted to show that real quick so you guys are aware. Let's do the next slides here. Okay, same kind of deal there. We can go ahead and... okay, I do want to touch on this a little bit. So 2 types of generators. You have your whole home standby generator, and you've got your portable generators. So the nice thing about your standby generators is that their THD is way less, so they're a lot easier to connect to. They tend to be more powerful, so you can use them in some more interesting ways for the customer if they have one already. And 2-wire start is pretty much standard on standby generators. So those are pretty nice to have, but let's be honest, a lot of folks have their portable generators as well. So their THD, their total harmonic distortion, tends to be 20-25%. Most inverters have a real hard time connecting to these generators. And we've actually spent a lot of time, and we've done some really cool things with software and hardware so that we can connect to pretty much anything. I've yet to have a generator that we can't connect to. Now, obviously, if you have the option to buy a generator that has a lower THD, it is easier on everybody involved. So I do recommend picking one with the lower THD if you have the option. But if the customer wants to make use of the resources they already have, we can make that happen. We are only compatible with 240 volt generators, though, just so you know. It's got to be 240 volt or 208 volt if you have a 208 volt configuration. But 120 volt is not going to work. Okay, that's it for that. Let's go to the next slide. Here we have another wiring example. This is the standard install plus a standby generator. So we do recommend that you do the wiring a little bit differently for a standby generator than a portable generator because of their kW capacity. In this case, if you only have one solar, so for instance an 8K install or a single 12K install, you would want to use a transfer switch so that you could power the entire panel. Additional loads, because your 10 kW plus generator is going to be able to do more than the solar by itself would be able to do off of batteries. But as a reminder, our off-grid at night, off-battery only AC output is limited to 8 kW. So if you have a bigger generator, you would benefit from setting it up like this so that you can power everything in the panel and then we just charge from the panel as if the generator was the grid, basically. And this is an example where you'd be using the grid input breaker for a generator. So whenever that's happening, that's totally fine. We can do that. We can tell the difference between the grid and the generator. But it is important that you select this Gen Connect to Grid input box in your cell control tab. That lets us know to look out for a generator, because as you probably know, you don't want to try and sell back to a generator. There can only be one winner, and in this example, it's going to be the generator. So we do need to know that it is one, so check that box. Two-wire start is literally just we close the relay, so we short the two connectors, so it's pretty straightforward. You can use that for most standby generators, as I said before. Even some portable generators can be rigged up to work with a two-wire start, so that keeps everything automatic. You can set it up to whatever state of charge or voltage you want the generator to be called for, and then we'll do that all automatically. All right, let's go ahead and move on. So here is the same kind of thing, but with a portable generator or a smaller generator. So we would just use the generator input breaker in this example, and it's a little bit easier to follow. A couple notes on your settings, though. If you're going to be using a smaller generator, because it does have a higher THD, as I mentioned before, you will want to, you'll probably want to do this for any generator, but especially portable generators. You see this, the screen in the top right here, you want to expand your frequency range. So you want to up the allowable hertz to 65 and the low end to be 53, and that lets us stay connected to the generator more easily. You can also widen this frequency range if you're on an island or you're somewhere where the grid is particularly bad, so that we tolerate more fluctuations in the grid, so you're not constantly connecting to the grid and disconnecting to the grid, which will improve your relay life in the inverter. So that's always good. We can also, here at the battery setup screen on the bottom in the charge tab, you can select your gen charge values independently of your grid charge values. So if you want to avoid overloading your generator, you can adjust how many amps will charge from the generator versus charging from the grid, and so on. That also happens to be the screen where you plug in your battery charge settings, but that's pretty straightforward. Just look at a reference sheet in the manual or the manufacturer's suggestion. All right, next slide. Okay, so we can do grid/generator peak shavings, which is kind of like a generator assist in some cases. Essentially what this does is you can set a threshold, and we'll use those current transformers in the event of grid shaving, or if you're using the generator input breaker on the 12K, you actually don't need to use the CTs for that feature. But if you're using generator peak shaving on an 8K, you will still need the CTs. Because we added some more internal CTs on the 12K. But essentially what you can do is you set the threshold. So let's say you had a really undersized generator. Maybe it's only like a 5 kW or something. And you want to be able to turn the generator on when the batteries are getting empty, but instead of just passing through all the power from the generator and potentially overloading the generator because it's smaller than the inverter, we will measure how much power it's putting out, and if it hits the threshold value that you program for it, so if it's a 5 kW generator, I'd recommend setting your threshold at either 3,500 or 4,000. And that way, if you hit that threshold, the inverter will actually step in, discharge the batteries, and contribute to the loads to keep the generator from being overwhelmed. And then whenever that load dissipates below that threshold value again, the inverter will start charging again. Pretty nice way to take advantage of smaller generators. And then, of course, this can also be used for the grid. So places that have like demand response pricing or demand pricing, you can set a threshold for the home or the building and make sure that you don't exceed that. So the inverter will step in to keep it below whatever that threshold value is to avoid those kind of expensive demand charges. So the last thing I want to mention here is you see that circle around auto detect home sensors, home limit sensors. There's like 16 or 64 different ways that you can install the CT sensors, and without this feature, there's only one way that works. So that was a challenge for a little bit to make sure that that was done correctly every time. So we came up with this feature here where the inverter, as long as you have batteries, we will do some cool stuff with selling back and just a little bit buying back, and we will automatically detect the orientation that your sensors are in and treat them accordingly. So that's a really handy feature to have. Oh, and here on the right, you'll see that there's, in your time of use settings, there's these boxes on the far right called Gen versus Grid Charge. These, if you are using time of use and you want the generator to be able to be called for, you have to have a check mark in the Gen Charge column for each time slot. And if you don't have a checkbox there, it's what's considered quiet time. So even if you hit the start percentage or start voltage, we will not call for the generator. So this is useful for two things. One, if you have a customer that's off-grid or something and they don't want to be woken up in the middle of the night with a loud generator, that's cool for them so that they can avoid that at a particular time of night. And the second thing that you can do with that is prevent the generator from running for extended periods of time. So you could have it go every other time slot or something like that and limit the run time to 3 or 4 hours. If you wanted to, say, not run the generator right before the sun comes up, because you can just use the sun in that case, or whatever the case may be for your install. But let's go ahead and move on to the next slide. All right, so here we have our first meter zero limited to home example. So you install this the same way as one of the previous standard installs. It's just in this case you're going to be programming it to limited power to home. And as I've mentioned a couple times now, we measure how much power the house is using, and we will backfeed the house only up until that equals or is less than how much power the house is using. So this is a way to get around. You can not have a net metering agreement, but still save a bunch of money on your bill. So as far as the grid knows, you're just using less power on the property. So it's a pretty handy feature to have. That's pretty much it there. So let's go ahead and move on.
Probably.
Time of use, grid cell, lithium battery. Okay. So this is actually the most popular way to program the system, is to have it in grid cell, limited power to home, and time of use at the same time. And what that means is during the day, whenever solar power is available, we will basically be grid tied. We're going to sell as much power to the grid from the panels as possible, keep the batteries full. And then whenever the sun sets and you don't have any PV power anymore, we switch over to limited to home mode for time of use selling from the battery bank. So we will, actually, let's go ahead and go over that chart on the right. So you have time, power, battery, and then the two charge checkboxes. So the time is just whenever you want this behavior to start, and it will happen from that time slot to the next time slot. The power is how many watts are going to be used specifically from the battery bank. It doesn't include solar. It's just the battery discharge. And it'll use that much power until such time that the battery hits whatever the percentage or voltage is in the battery column. So in this example, at any time of day, I'm willing to sell up to 2,000 watts to offset the house's power usage from the grid until such time that my battery hits 40% state of charge. And then again, you've got if you did select a grid charge for a particular setting, it will use the grid to step in and keep the battery at whatever that minimum is for that time slot. So in this example, if I had grid charge selected for 1 a.m., the system would not let the battery go below 40% if the grid was available. One other really important thing is on any install, on the second screen here, the discharge tab, it's very important that you use this battery empty voltage box here. 47 volts is kind of the default for a lead acid battery, but if you're using a lithium battery, it's even more important to use this. Usually for lithium iron phosphate, it's something like 50 or 51 volts that you would put here. But what that does is actually two things. It defines the 0 to 100% range for our SOC calculations, and it also will protect the battery from being overloaded. So if we hit that voltage under load, we immediately will shut down the inverter so that we prevent the battery from shutting itself down while the inverter is trying to power a load. Because if you remove battery power from our system while it's powering a heavy load, that can cause problems. So we want to protect both the inverter and the battery from being tripped with that feature. Okay. I think I got a question here. Let's see. Is it possible to change these parameters remotely? It is on the 12K, and you can buy a dongle for the 8K to make it remotely accessible as well. But for the 8K, it's an additional feature for $100. For the 12K, it's standard. Okay, so stacking. The 12K is capable of stacking. The 8K is not. So you can do up to usually about 8 12Ks in parallel, and you can do that for 12240 or 12208. The setup is basically you're going to have one master and however many slaves you have for the 240 volt version of stacking, and it's not quite a perfect addition, but it's pretty close to perfect addition on adding this up. So if you have 2 inverters, you're going to have double the pass-through current and pretty much double the battery backup power. And all you do to set this up is you pretty much just put everything in parallel. So the the load outputs are going to be paralleled. The grid inputs are going to be in parallel to the grid. Something to note, though, is only the master gets the CT sensors because it's controlling the show. So it'll be controlling like limited home mode, for example. You would only plug those into the master. We are about to release 208 software for stacking, and this arrangement does change a little bit for 208 in terms of who gets CT sensors and how many masters and slaves you have, depending on how many inverters you have. It gets a little bit more involved, but it can be done. You can do up to 8 inverters that way. And we're going to be releasing some diagrams on that here shortly, but don't want to go into that too much right now, other than we can do it, and we can stack pretty heavily that way. Let's go to the next slide here for a little bit of programming on this. All right, so here's an example of the programming for the above example. You basically just go to your basic setup menu, go to the parallel tab, and put both units into parallel mode. Obviously, one unit in this example is going to be a master. The other is going to be a slave with those little little circles there that you can check. The master always gets Modbus serial number 01, and then the slaves will be 02, 03, 04, etc., however many of those you have, up to 8. Again, all sensors connect to the master, including temperature sensor, temperature sensors, CT sensors, etc. The master unit is going to control charging as well. And, this is very important too. All systems in parallel need to share one big battery. You don't give each system its own independent battery bank. They all need to share one big battery in parallel. All right, I think that's it for there, unless we have any questions. Okay. So, voltage and frequency ride-through. This is a UL 1741 SA feature. Very important for unstable grids and islands. It's actually required on most islands by like HECO, PREPA, that kind of stuff. So we do have some reference material in the manual for what these settings need to be in those cases. But basically, this is a way to program the system's tolerance for a sloppy grid connection. So it's basically just exactly what it looks like. So if you hit that higher voltage of like 264, it'll tolerate that for 1 second, versus 211, it'll tolerate for 20 seconds, etc. And you can kind of play with these settings if you need to, or put them to what you have to for your location of install. The power factor settings on the right here, these are kind of cool. This lets us dynamically change our power factor settings to basically improve the grid. So the islands really like that feature. And if you're using AC coupling off-grid, I also recommend turning on the QV and the FW here at the top of the screen on the right, because that'll improve our ability to deal with voltage fluctuations and frequency shifting on basically low AC production. Kind of a mouthful, but basically what it does is sometimes if you have AC coupled panels when you're off grid, lights will flicker because of fluctuations, and this helps fix that. So that's the short answer to that. Moving on here, rapid shutdown. So for NEC 2017, basically module level shutdown, we do prefer to use, well, first of all, you can use pretty much whatever you want. This example here is for Tigo, though. That's our most commonly used rapid shutdown solution with the Solarcs. So basically, you'll have a transmitter that does power line communication. You'll put all your positive wires through their little toroid. We do provide a 12-volt power supply from our unit to the transmitter. You'll throw a little normally closed button over by the meter that will cut off the power supply to the transmitter. So if you wanted to initiate rapid shutdown, you would just press that button, kill the power to the transmitter, and that would initiate rapid shutdown. Another way to do that would be to press the power button on the front of the Solarc. That'll cut battery power to the transmitter and also initiate rapid shutdown. So you just have one transmitter and one receiver per panel, and that's pretty much everything involved. If you need to do like 2014, if anybody's still doing 2014, string level rapid shutdown, I'd recommend using the Midnight solution. That's same idea though for the wiring. Anyways, yeah, next slide. So we have lots of communications capabilities. We do have CAN bus, RS-485, Modbus, FunSpec. We're using these communication protocols to communicate with batteries, BMSs. We're working with Discover. We're working on Fortress. We're doing a bunch of the other battery manufacturers, pretty much all of them, actually. Almost all the major players are working with us to try and get this working, so that's going to be a really good selling point for a lot of customers. A lot of consumers like that ability to talk to the battery. And then, of course, we're also competing in the American-Made Solar Prize, and we've already actually been awarded a semi-finalist prize towards utility communications and getting like DERMS working, IEEE 20.30.5, and that kind of stuff working for utility communications. Not quite ready yet, but we are working on it, and we are already winning awards on it. So with that, thank you. Any questions for either of us?
And understandably, guys, I mean, this is a lot to digest, so we understand if you didn't get it all on the first round, we're going to be sending through the deck to UMA so they can share it with you guys. And this is also recorded, so you can always go back through it and you know, review anything. And of course, any questions about what we presented today and whatever is you know, in our manuals, which are all online, you can call us anytime. You can call UMA. We're more than happy to walk you through some of these things. Again, we understand for some it's pretty easy. Maybe you're very experienced, but for others it's very new and maybe overwhelming. And so don't worry. We're a patient bunch. So, any general questions?
Okay.
Is stacking possible for three-phase?
I do see a question real quick. Yeah, three-phase stacking. Yes, it is possible. You go in groups of 2. So 2 units is the minimum to do true three-phase backup for like 120, 208 star configuration. So 2, 4, 6, or 8 you'd be able to do for three-phase systems. It might technically work for the odd numbers in between, but you'll have more power on one leg than the other. So I recommend doing just the groups of 2 there. Where are the solar converters manufactured? Well, they're designed and final assembly is in Texas, and we do all the support from Texas, but they are made in China. It just is what it is. The main weakness of your product? Well, I'll usually think too much about the weaknesses here, but yeah, go ahead.
We get a lot of questions about. I get at least 2 or 3 a week about large jobs. You know, anything above, I'd say 120 kilowatts on the small commercial side because of our true phase capability. I get a lot of questions about that. Honestly, that type of application tends to be more suitable for a high voltage inverter, like a 480 volt. So we're happy to look at those things with you, but we're also, you know, we want to find you the right solution. and generally those really large jobs probably aren't the best fit for us. You can always ask us, but if it's really if it's a 100-kilowatt array or smaller, that's really our wheelhouse. Yeah.
Okay. And then California Rule 21 compliance. No, I totally agree. We're a really good solution, and we're very versatile up until you hit about 120 kilowatts of PV. And then once you get bigger than that, yeah, we're probably not the right solution for you. But less than that, we do a pretty good job. The California Rule 21 compliance we do currently have, and we are working towards the next iteration rules on that that's going to be due in June, I believe it is. We should be ready by then as well. So should be good.
I got a question. Can you hear me okay?
Yes, go ahead.
Hello? For residential install, the CTs that you have with that you said are programmable, is that correct? That you have the CTs that you can put into individuals, so that how many CTs I guess does it come with? When you just order the regular 12K.
Oh, okay. I think I know what you're asking. So you're only going to get two, and
okay.
we don't do individual load monitoring.
Okay, that was my question.
Total load of the house. Yeah.
Gotcha.
That does remind me, though, the CTs that come with the unit are big enough for 2-aught copper connections, but we do have 4-aught, like aluminum wiring connections available upon request. So if you have a larger gauge supply, just let us know.
Okay. I was just wondering about as far as what all it's monitoring as far as consumption goes.
Mm-hmm.
So is it just it's just monitoring the overall consumption in the overall output?
Right. Yeah. The Solarc itself, with the default and what it comes with, is only going to measure the total usage of either one panel, like one service panel, or the whole property.
Okay.
Not individual loads separated out. Now, if you do want that kind of monitoring, there are third-party solutions for that. I think there's eGauge and NAC and some other stuff out there that can do that.
Yeah, I just didn't know if that was upgradable with this program or not.
Anything's possible in the future, but because we do have Modbus communication and that kind of thing, but at this time it's not supported. So.
Okay, thanks.
Hello?
Hi, Randy.
Hey, yeah, I have a question. Can you hear me okay?
Perfect.
Okay, perfect.
Yeah.
You had mentioned about when connecting to like the main distribution panel versus how you guys recommend using sub panels, because you were saying there could be potential neutral pathway problems. Any chance you can expound on that a little bit? Just because we have a lot of installations where obviously it's sort of a retrofit, and it's not the existing setup isn't really conducive to properly, critical load setups, right? So it's more so you get the best we can do. So I just wanted to hear a little bit more about that.
Sure. Okay. Yeah, what I was referring to is if you have a home that was built more recently that comes with those arc fault or arc fault / GFCI breakers in the main service panel,
Mm-hmm.
If you don't use a real sub panel, then the path that the power takes back through the neutral is going to go back through the main service panel, but the L1, L2 actual power will be going through the breaker and the transfer switch. And because those don't match, you'll pop that breaker and remove the neutral from that circuit. But it's a pretty rare problem. So if you have an older home that just has regular breakers, don't worry about it. You can use a transfer switch, like a 10-circuit Reliance Controls transfer switch as your sub panel. Easy, no big deal. It's only the newer homes that have those arc fault breakers that you would need to use the sub panel. Now, there is also another solution to this problem, and that would be powering the entire panel from the get-go and not even bothering with any kind of sub panel. but that usually for most homes is going to require 2 systems or more, but you can do that route as well.
Okay, understood. Thanks.
All right. Well, any other questions, guys?
Can you remind me what's the voltage of the batteries that would connect to yours?
So the voltage range on our DC input for the battery bank is going to be 43 to 59 standard, and we have another, upon request, we have a model that goes from 43 to 63. And that's going to be our voltage range. So basically 48 volt nominal is what we're going for.
Okay, and you sell your own batteries, or you recommend third party?
We do sell a battery, but it's mostly for EMP customers. That's another thing I should have mentioned. We do have a defense background as a company, so we do offer something called EMP hardening for our products upon request, an additional fee. And basically, lead-acid batteries are immune to EMPs, so we do carry some of those for those customers. But other than that, for most cases right now, honestly, lithium iron phosphate tends to be the best bet for most customers most of the time. But if you have a particularly cost-conscious customer, or it's a battery backup only, like infrequent grid outage solution only, then AGMs are a pretty decent solution. So we do offer a carbon-infused, we call them PCC 230s. Information is available on our website about those. So, yeah.
Okay, and how much more efficient are those lower voltage batteries compared to the LG Chem high voltage batteries? You said that they're like 11% inefficient or something. They lose 11%.
Yeah, so the LG Chem is 11% just inside the battery, whereas something like a PCC 230 is only going to lose 2% round trip inside of it, so it's 99% each way.
Because they don't have to do a DC to DC
Pretty substantial.
already at their native voltage.
Correct.
Okay. Well, thanks. That answered my question.
All right. And guys, I would like to mention that you know, we have been getting some questions about, you know, our operations right now, and we are fully operational. In fact, we are accelerating our production. We are taking on more inventory in our warehouse, and we're here for you. Our lead times have not changed. They've actually gone down to a little around 1 week to get product to UMA. So we're you know, all systems go. So you know, we understand that things are maybe in flux and in the economy, or you know, in your local area, but you know, we'll be here. We're good to go. And so thank you guys. Any other questions? I know we're coming up on almost 90 minutes here, so that's quite a long time, and I really appreciate your attention and patience. Anything else? Otherwise, Doug, do you have any words you'd like to say before we wrap it up? Okay. Did everybody get that? Great. Well, again, thank you very much, everybody.
Well, thanks, everybody.
And again, really appreciate your attention. We're here to support. And with that, we'll call it a wrap. Okay.
All right. Take care, guys.